Hi guys, let's see if this video isn't as laggy as before. Looks like it's pretty up to speed. Okay, so this is your second math lesson in my class. Go ahead and open up your spiral notebook to your next blank page. And today's lesson is going to be titled Combining Like Terms. Combining like terms. So I'm hoping that the general idea of this is a review for you, and that might be the case for this whole trimester. Algebra Essentials is what we're calling this trimester. So it should be a review, but once again, I'm hoping to push you a little bit. We're going to talk about a lot of vocab today. I do want you to write it down, okay? So here's our first vocab term, algebraic expression. Algebraic expression. First of all, let's just talk about expression. There is a difference between an expression and an equation. So I'm going to write two different things. Which one of those is an equation? Yep, has an equal sign, so it's an equation. If there's no equal sign, but there are terms being added or subtracted, then this is just an expression, okay? Now, an algebraic expression, if it has this word algebraic, that means that there's a variable involved, or sometimes several variables, okay? So we're gonna write, this is our definition. Let me use a pen. Algebraic expression is an expression containing numbers, comma, variables, comma, and operation symbols. Okay. So let's go ahead and write an example of an algebraic expression. So let's start with a big old -8. But that -8 is right next to something. It is right next to the letter X. And then after that, we're going to add something. So write in a plus sign. And then we're going to end this with a 2. So our algebraic expression is -8x plus 2. Now, I'm doing it in different colors because, well, I just love colors, but also we have different vocab words for everything within here, okay? So let's first talk about this -8. This -8 has a name. It has a name, a special name, because it is right next to a variable. The number that's right next to a variable is called a coefficient. C-O-E-F-F-I-C-I-E-N-T. Coefficient. So coefficient is that number out front of a variable. And then this X, we know what that's called. That's called a variable. And variables can be all sorts of letters, right? A, B, C, it doesn't matter. In math, what's our favorite variables though? Which letters do we use most often? We use X a lot and Y a lot, X and Y. Algebra uses X and Y as our favorite variables all the time. Okay, now this orange plus sign, it has a name too. That is your operation symbol. So the operation that's happening in this expression is addition. All right. And then lastly, we got this 2. Now you're like, there's no fancy name for that, Meineke. That's just a 2. Well, if you have a term like this where it's just a number and there's no variable attached, there is a name for that. It's called a constant. It's not multiplying by a variable. It's just constantly plus 2. That's it. Okay, it's just a 2 there. All right, so let's go ahead and we're going to talk about at least some of these. Let's talk about a coefficient. I want you to submit this to memory because I use this word all the time. So when I say things like, what are the coefficients of blah, 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 I need you to know what I'm asking, right? So coefficient, we have to have that word in our vocabulary. So it is a number that's being multiplied by a variable. A number that's being multiplied by a variable. Now, I wrote multiplied because I do need you to know that when a number like -8 is right next to a variable, what's secretly happening there is multiplication, okay? So I want that word multiplied in your definition, but how I think of it, like just in my head, I go, oh, that's just the number next to the variable. So like the definition in my head for coefficient is number next to variable. But I do want you to know that because they're next to each other, it means that they're multiplying. I think that's important. Okay, so let's go to constant next. I always confuse my kids because I think it's because they both start with C. But coefficient is out front. A constant, this 2 was a constant, and it's called a constant because there's no variable attached to it. It's just a lonely number, okay? So that's kind of what I write, is just it's a number by itself. It's still a part of this expression, obviously, but it's by itself in terms of like, there's no variable attached, okay? Now, we're talking about combining like terms. Well, we have to know what a term is. I've already used it a few times in this video. So we need to talk about what a term is. Term. So here we go. We're going to write it and then I'll explain it, okay? Term is a single number. And what I mean by single is it's a number by itself. So we could use some vocab here and say it's a constant, comma. Okay, so a term could be a constant. So like this 2 is a term all on its own. Okay, but comma, it could also be a variable, comma. So if I were to add like plus W, that'd just be a variable by itself. Okay, so that would be considered a term on its own. And then or the product, fancy word there, the product of a number and a variable. Okay, so pause the video if you need to. Get that all written down. And then let's go ahead and talk about what this means. So 2 is a single number, it's a constant. Therefore, it's a term. So 2 is a term. Okay, and in fact, I'm going to take a pencil and just kind of circle this 2. That's a term. Okay, now a variable. So just a lonely variable. I don't have an example of that in here. But like I said, if I were to like, add a W or something here, that would be just a variable all by itself, okay? But right here where it says the product, what does product mean in math? We got product, quotient, sum, and difference. Product means multiplication is happening. So right here, this is the product of -8 and x. So that right there, the product of a number and a variable, that's also considered one term together. Kids get this confused because they're like, wait, but that's -8 times x. Two things are being multiplied. I agree with you, two things are being multiplied, but together they make one term. So why am I saying this? Well, this expression, I'm going to pretend the W is not there. This expression has how many terms? Has two terms. This is a term and this is a term. If I were to add the W though, how many terms would it be now? It would be 3 terms, okay? So another way kids think about it is they just look at how many operation symbols there are and they go, oh, well, since there's 2 operation symbols, those separate the terms. I got a term here, term here, term here, okay? So if you like that way of thinking about it, you could write yourself a special note and say terms are separated by plus and minus signs. Okay, that could be a special note that you write. So let's practice some vocab. I'm big into vocab. Not only does it make you sound smart, but it's just like needed. It's needed in math. We have so many different things. Okay, so we're gonna have example A and example B. We're testing your vocab here. Coefficient, constant, terms, yeah. So A is gonna be -3y minus 6. And B is gonna be 13x minus y plus 2. So get those examples written down. Pause if you need to. I'm going too fast. But here's what we're going to do. I'm going to test your knowledge. I'm going to ask you 3 things about these. I want to know what the coefficients are. I'm going to abbreviate because I'm lazy. I want to know what the constants are. And I want to know how many terms or the number of terms that are in that expression. Okay, so I'm going to go through with you on this one. Coefficients. I look up at my definition, a number that's being multiplied by a variable. Really how I think about it is the number attached to the variable, okay? So there's my variable, y. Y is my variable. What number is attached to it? What number is smack dab right next to it? I hope you didn't say 3, because that is not a 3. Look at the sign in front of it. We always keep the sign that's in front of it. That right there, my friends, coefficient's a -3. Okay? All right, constant. Constant is a number by itself. So it doesn't have a variable attached, just by itself. So what's the constant in this expression? I hope you're looking right here, but careful. Is that a 6? Or is it a -6? Keep the sign that's in front of it. Always, always, always keep the sign that's in front of it. That, my friends, is a -6. If you're like, what? No way, Miss Meineke, that's subtracting 6. Well, guess what, my friends? You could also write this as -3y added to -6. It means the same thing. I would hate for you to write it this way because having 2 operation symbols just freaks me out like that. But technically, it's the same thing. Okay, that 6 is negative. Take ownership of that. Last one. How many terms? How many terms are in this expression? 1, 2, 3, 7, 5. If you're getting confused, go back here. Terms are separated by plus and minus signs. Here's what I'm seeing. This -6 is a term. Okay, so that's a term. Okay, because that's a constant. A variable. I don't have any single variables hanging out, but I do have the product of a number and variable. That's right here, -3y. So how many terms is that? 2 terms. Okay, now this one, you're going to do the same thing. I want you to tell me the coefficient. I want you to tell me the constant. I want you to tell me how many terms are in the expression. I challenge you to pause the video, think about this without me, hit play when you're ready to check. Okay, I tried to trick you on this on purpose, okay? Coefficients. Coefficients are numbers in front of variables. Well, how many variables are in this expression? There's 2 variables. So guess what? If there's 2 variables, then there's 2 coefficients. 13 is in front of x, so that's definitely a coefficient. And then some of you are like, Meineke, you are losing your marbles. There's no number in front of y. Well, yeah, there is. Yeah, there is. If there's no obvious coefficient, then there's always a secret one. I'm hoping some of you knew that, okay? Now in this case, is the coefficient 1 or is it -1? 1 or -1? Keep the sign that's in front of it. You best be putting -1 on your paper, okay? So the coefficients in this expression are 13, +13, and -1, okay? A constant, there's only one term that doesn't have a variable, and that's this dude right here. So 2 is the constant. And then how many terms are there? 13x is a term, -1y is a term, 2 is a term. There are 3 terms there. Okay, this page was all about vocab, but now we need to get into actually knowing what like terms are and how to combine them, okay? So this is all prep work. So we have one last vocab thing. We know what a term is, hopefully. Now we're going to learn what like terms are. This typically is an easy concept for kids to get, but there's some things that you kind of have to watch out for. This might seem silly that I'm promoting myself on Instagram right now, but if you have an Instagram, I have a teacher one and a real one, okay? You can totally follow me on my teacher one, okay? It's at Miss Meineke, just have to spell my name right. Last spring, I started doing this and I made like kind of some silly math videos or just trying to connect it to like real life situations. I have a really good one on combining like terms. When did I post this? May 13th. So if you go back to May 13th, it has like some videos of me kind of walking through some problems and whatnot and talking through it. I do think it's valuable, okay? So feel free to follow me on Insta. Okay, anyways, like terms. Like terms are terms that have the same variable raised to the same power. Terms that have the same variable raised to the same power. That's what's key here. Same variable, that means like x's go with x's. X's can't be combined, can't be combined with y because they're not the same variable, they're not the same letter, okay? But we also have to keep this in mind. Not only do they have to be the same variable, like an x and an x, but they have to have the same power. Now, if you're confused on this word power, let me help you out. Power is the same thing as exponent. I might also say the word degree because they mean the same thing, okay? So they have to be raised to the same exponent. Same letter, raised to the same exponent. That's the only way you're going to combine them. Okay. So let's just go ahead and practice. Here we go, y'all. Practice. Some of you, I think, are going to do excellent on this. Feel free to just kind of like copy down, pause, don't listen to me, check your answer. If you get it wrong, rewind, listen to my explanation. Okay, so number 1, 14y plus 10 minus 3y minus 2. All right, so I got an expression here. I noticed that there are 4 terms, and I'm going to try to combine some things. Now, combine means add or subtract. Okay, we're not multiplying anything here. I'm combining some like terms. So I just start from the beginning, 14y. My variable is y. So I can only combine it with other terms that have a variable of y raised to the first power. Technically, there's a secret exponent 1 there. Well, I see this negative 3y. Notice how I circled the negative in front of it because it's negative 3y. So 14y and negative 3y are friends. They are like terms. They have the same variable raised to the same power. So if they are like terms, we can put them together. What I mean by put them together is I can add or subtract them. So in this case, you got 2 ways of thinking about it, everybody. You can think about it as 14 minus 3. So you're just like subtracting the coefficients right there. Or you can think about it as 14 plus negative 3. Either way, like you're going to get 11 as your coefficient. 14 minus 3 is 11. So 14y minus 3y is positive 11y. Okay, so you're just combining the coefficients. Notice how this y did not become y squared. And that's because you're not multiplying y with y. You're basically just organizing and putting all your y's together, all your x's together, all your constants together. Okay, it's like 14 dogs, take away 3 dogs is just 11 dogs, not 11 dogs squared. That doesn't make sense. Okay, now let's go ahead and look at what's left. I have a 10. 10 doesn't have any variable, meaning it can only be put with things that also don't have variables. Those are called constants. So your constants can definitely be put together. Positive 10 with a negative 2. I think of it as 10 minus 2, which is 8. And since that 8 is positive, I put a plus in front of it. My final answer is 11y plus 8. Now this is where some of you have your pencil ready and you're like, oh, that's 19y. No. You cannot put these together. They are not like terms. They do not both have y's on them. So you're done. Final answer, 11y plus 8. Number 2, negative 5x minus 6 plus 2x. Sorry. Pause, check your answer. Here we go. Negative 5x, I just go from left to right. Negative 5x, I'm searching for anything else that has an x attached to it, like this dude. Negative 5x can go with this positive 2x. Careful with your negatives here, use the calculator if you need to. Negative 5 plus 2 is negative 3, so that together would be negative 3x. And then this negative 6 doesn't have anything else to be combined with it, so since it has no friends, you just drop it down. I cannot go any further because these right here are not like terms. That's my final answer. It's as simplified as possible. Okay, next up, 8x plus 3 plus x plus 4x squared. Pause if you think you can do it. I think you can. Okay. 8x. I'm searching for any other terms that have the same variable. Well, I see an x, and I also see an x squared. Question is, do they all get put together? Remember, they got to have the same variable raised to the same power. So what that means to me is 8x can be put together with x. But guess what doesn't go with them? This x squared is not a like term because it has a power of 2. It has an exponent of 2. Okay? Anyways, we got 8x and this x. Now remember, I don't see a coefficient in front of the x, but what is secretly the coefficient then? 1. So 8x plus 1x is 9x. Okay. Now this 3, the 3 is your constant. I don't see any other numbers that don't have a variable. So I'm just going to drop that guy down. And then the 4x squared. 4x squared doesn't have any friends to be put together with it. So I just drop it down. Okay. Now I would accept this as your final answer, but because you're in high school, I'm going to push you a little bit further. This bugs me as your final answer. It's not technically in descending order, which means the highest exponent out front, the term with the highest exponent. This 4x squared has the highest degree, the highest power. So technically you would plop that out front. So positive 4x squared, followed by the next highest power, which would be this 9x, positive 9x. It technically has a secret power of 1, secret exponent of 1. You can write it or just leave it. And then the 3 doesn't have a power at all. So that would be the final answer. If you need help on that, we can talk about it in class. And then next one, negative 4y plus 2 plus 4y minus 10. Try that one out. Okay, so here we go. Negative 4y. I'm looking for other terms with y in it. Here we go. I got a negative 4y and a positive 4y. What's going to happen there? What's negative 4 plus 4? It's 0. So you would have 0y here. You know what? I don't even take the time to write 0y because 0 times y is 0, right? Anything times 0 is 0. Meaning, why would we put like 0 plus something? You just would leave it off. So I don't even take the time to write 0y. I just go like this. Oh, they cancel out to nothing. Okay, that's what I do. And then I see what's left over. I got a positive 2 minus 10. 2 minus 10 is negative 8. That's my final answer. Okay, so it is possible for terms to cancel out like that. Okay, these last two problems, I can't even count. This is number 5. This is number 6. We will correct these last two problems in Zoom class. So you need to do the work now, have your answer ready for class. Okay, here are your problems. 5x squared plus 2y squared minus 10 plus 4. Okay. Next up, 10y plus 8x minus 10x plus y. Okay, so those two problems, I want them done before you come to Zoom class. Thanks for watching, appreciate it. See ya.